This video is about depth perception, specifically how the use of both eyes enable us to perceive depth. So if you have the use of both eyes, your depth perception is innate. We see the point in the visual field, we see the point in our vision where our visual fields overlap when we do this magic sausage trick that I have linked on your slide for you to try on your own. This little sausage that appears here, the floating sausage as they call it, is showing you the point where your two visual fields overlap. So if you recall what we've already learned about visual processing, we know that information in the left visual field of both eyes is processed by the right hemisphere. Information in the right visual field is processed in the left hemisphere. But these two visual fields, when they are combined, create our perception or enable our perception of depth. It enables us to know how close or how far away objects are to us. So one type of binocular cue that you have to know is called retinal disparity. And all this means is that the space between our eyes allows the brain to determine the relative distance of different objects. We see a greater disparity when we're looking at nearby objects than we do viewing ones that are farther away from us. And this picture here is just showing you how when information from each visual field is combined, it enables us to perceive depth. It enables us to see, for example, that this dog is closer than this dog. Other binocular cues are convergence and accommodation. I haven't seen these ones commonly tested on the AP exam, certainly not to the extent that retinal disparity has been tested. But convergence occurs when we're watching an object that's close to us. Our eyes will point slightly inward. And the difference in the direction of our eyes is referred to as convergence. But this depth cue is effective only on short distances. So we're only using it when we're viewing objects that are less than 30 feet away. Accommodation is the tension of the muscle that changes the focal length of the lens of the eye. So it brings objects into focus at different distances. But this depth cue is very weak, and it's only effective at viewing distances that are less than 6 feet. So again, just coming back to retinal disparity to review, the space between our eyes mean that each eye takes in a bit of a different image, and when those images are combined, it enables us to perceive depth. Just remember, binocular cue meaning two eyes. So this is how we perceive depth using both eyes. If we don't have the use of both eyes, or if an object is very, very far away, say like a plane flying overhead, what we're actually using are called monocular cues for depth perception, or cues that can be perceived by one eye to create the illusion of depth. And you're going to learn about that in the Flip It video that you watch.